Welcome to the first lesson in Chapter 1, Introduction to Web Development, and Chapter 1 is going to deal with how web applications work. In this lesson, we'll be examining how web applications work. We will focus our time on to describe the components of a web application. We're going to distinguish between the internet and the intranet. We're going to describe HTTP requests and responses. We're going to distinguish between the way a web page processes static web pages versus a dynamic web page. We're going to name the 5 major browsers. And of course, we're going to have a little brief description on the use of JavaScript. So let's begin. The World Wide Web consists of many components that work together to bring a web page to your desktop over the internet. Before you begin to start designing and creating web pages, you should have a basic understanding of how these components work together to create a web experience. So, what are web applications and how do they work? Web applications consist of clients and a web server. The clients are the computers, the tablets, and the mobile devices that use the web application. These clients access the web through programs known as web browsers, and the web server holds the files that make up the web applications. A network is a system that allows clients and servers to communicate, and the internet in turn is a large network that consists of many smaller networks. Moving right along, let's examine the architect of the internet and how you're able to connect to it through vast amount of information. Networks come in all shapes and sizes. Networks can be a single phone accessing the internet to access a social media app, and can include a cluster of computers and network devices that share information locally, such as these school computers. They are part of the school network. That is known as a LAN, a local area network. Typically, computers can share a LAN, are in the same building or adjacent buildings, and can share storage, printers, web applications. This type of structure is also known as an intranet and is primarily used by employees and students. So every time you sit down to one of these computers and you log in with your user login name, you are actually on the school's LAN or intranet. WANs, or wide area networks, consist of multiple LANs that have been connected together over long distances using routers. The routers route information from one network to another and can be owned privately by one company or shared by multiple companies. WANs connect to the internet through the internet services, or also known as ISPs, and these ISPs lease access to WANs and individuals to connect to the internet. An example of a WAN that we have at this school is that we have a Charlestown campus and we have a Chelsea campus. And it doesn't matter where you log in, if you're in Chelsea or you're in Charlestown, but you will be able to access the same information, same folders, same storage devices. Finally, the internet is a global network consisting of multiple WANs that are connected together. The ISP connects their LANs at large routers called the Internet Exchange Points. These are also known as IXPs. And it is this connection that allows anyone connected to the internet to share information with anyone else. Now that you've memorized the architecture of the internet, let's move on how a static web pages are processed to a web browser. And here's an example of a static web page. So what is a static web page? These types of pages are all over the web. So what are they? Static web pages are web pages that only change when a web developer changes them. A static web page is sent directly from the web server to a web browser, and then the browser requests it. So let's take a look at this one. It hasn't been updated, you can see, since October 2011. And basically all the information that is on the page has been there for the last 4 years with no changes. So how do these requests happen? The process begins when a client requests a web page in a web browser. So you're at your Google Chrome or what have you. The browser builds a request to the web page and sends it over to the server. This request, it would help if I moved it along. So here's your client, and it sends the request. This request is known as an HTTP request and is formatting using the Hypertext Protocol, or HTTP, which lets the web server know that you're making a request. Once it's there, when the web server receives the HTML request, it retrieves the file from the disk, or from the server itself, the storage area. And this file contains the HTML information, and then the server sends the information back to the browser as part of the HTTP response. And then when the browser gets the information, it shows up in the page. And there you have it, a static web page that has been served up the same way every single time when a client requests it. Let's take a look at the next part. Dynamic web pages. These are all over the place. You probably have been to a dynamic web page 100 times and you didn't even realize it. A dynamic web page is a page that is created by a program or a script on a web server every time you make a request. The program or script that is executed by the application server based on the data that has been sent along with HTTP requests. So when you go to a site like Amazon and you type in a search in the search bar for a book or something that you want, you're sending an HTTP request to the web server, and the page the server sends back to display to the browser is a dynamic web page, and it could be different for everyone depending on what you're searching for. So here you can see how a web server processes a dynamic web page. Again, the process begins with the user making a request that goes to the web browser, through the web browser to the web server that contains the data that the dynamic page will process. The web server builds the HTTP request and sends it to the web server, and then the web server requests whatever data the application needs to process the request. And then once it gets to the application server, when the server receives the HTTP request, the server examines the file of the requested web page to identify the application server that it should go to. The web server then forwards the information or the request to the application server that processes the type of web page. So it goes back to the web server, it processes the page at the application server. The application server then retrieves the appropriate program script from the hard drive, and then it also loads any data from the user submission. After it executes the script, it generates an HTML page, and if necessary, the script will request data from a data server that's used. If necessary, the script will request the data from the data page server and use the data as part of the web page as it generates it. When the script is finished, the application server sends dynamically generated HTML page back to the web server, and then the web server sends the information back as an HTTP response to the browser, and then the browser displays it for you, the user, and this usually literally takes a second. This whole process is known as a round trip, and every time you go in, you put in a new request, this round trip happens again. Dynamic web pages let you create interactive web applications that do all of the types of processing that you find on the internet, including e-commerce applications. All right, moving right along, let's take a look at web browsers that are available for you to view the web. This is not an exhaustive list by any means, but these are the top 5 contenders. Google Chrome, one of the most popular web browsers that are out there today. Google Chrome runs on all major operating systems, so it doesn't matter if you're working in Windows or if you're working in Linux or if you're working in Apple, it will run. The next one is Firefox by Mozilla. This also runs on all operating systems and was built using source code from the original Netscape Navigator web browser. Internet Explorer by Microsoft. This is pretty popular because Microsoft gives it away with all of their operating systems, and it basically runs only on Windows, and it's still playing catch up to all the HTML5 standards that are out there. We also have Opera by Opera Software, which runs on all major operating systems. And last but not least, we have Safari that runs on Apple. The next thing we're going to take a look at is some of the server-side scripting language that you should just be familiar with. You're not going to learn it in this class, but it just is a good thing to know that it's out there. These are the languages that you use to develop dynamic web pages. One of them is ASP.NET. It is a Microsoft product that runs on Microsoft servers, and you know they're running ASP.NET when you see an ASPX extension. Not a big fan of it. The other one is JSP. On the other hand, this is a free open source language that is commonly used with Java servlets. JSP runs on Apache web servers, and you'll know that it's running when you see in the browser the extension is JSP. The third language, which I actually dabble around in, is PHP. It's another free open source language that also runs on Apache web servers. Cold Fusion is a commercial scripting language for Adobe that integrates well with Flash and Flex. Its pages has a CFML file extension, and it is an extremely expensive product. Ruby is a free and open source language that is typically combined with Rails, and Rails is a framework to simplify development. And you'll notice in the browser, in the address bar, the extensions are RB. Perl is a free and open source language that was originally designed for use in Unix command line to manipulate text it has a PL for Perl extension. And last but not least is Python, another free and open source language that can be used to develop many types of applications on the web and has a PY extension. All right. The client-side JavaScript fit into web development. In contrast to the languages we just saw, which are all server-based languages, which means that they reside on the server, they get executed on the server, and when you put a request in, you have to do a round trip to the server and then have the information sent to your browser. JavaScript, on the other hand, is all done locally. It's a language that is provided on the client side, so it's all loaded at your computer right there at your browser. Some of the things that is useful that you probably already have used is when a visitor requests a page, such as the one that you see here on your screen, all the images are loaded to the browser at the time of the request. Then if the user clicks on one of the color swatches of these shirts, it will change dynamically with the new color, and it will do what's called an image swap. If the user moves the mouse over the shirt, the image will be replaced by whatever close-up image of that shirt, resulting in a rollover. Here you can see how JavaScript works. When a browser requests a web page, both the HTML and the related JavaScript are returned to the browser from the web server. Then the JavaScript code is executed on the web server. Then the JavaScript code is executed in the web browser by the browser's JavaScript engine. This takes some of the processing burden off of the server and makes the application run faster. Often JavaScript is used in combination with dynamic web pages, but it can also be used with static web pages. Besides image swaps and rollover, there are many other uses for JavaScript. Another common use is to validate the data that a user enters into an HTML form before it is sent for processing. This saves unnecessary trips to the server. Other common uses for JavaScript is to run slideshows and rotate headlines, or produce in one area of a web page and provide animation. In fact, whenever you see a portion of a web page cycling through a series of text blocks or images, that's probably being done by JavaScript. So that's the first lesson for chapter 1. I recommend now that if you haven't, go back and read the chapter and then answer the questions and keywords for this session. Thanks and have a great day.